Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Hello listeners, we are from Group
7.
We have Rika.
Yeah, we have been waiting for it. Hello.
We have Ananda,
Hello, guys.
Muthia,
Hi.
and of course myself today. Myself as host today. Okay, so our theme for today is science.
Well, that is interesting. Of course, yeah.
Oh, that's nice to hear. You guys must know about the multiverse, right? Well, I'm a bit curious of your understanding about it. Nanda?
Yes, so the multiverse is like a hypothetical collection of potential diverse observable universe, each of which was complex, everything that is experimentally accessible by connected community of observers. Like here is the theory of the multiverse suggests that our universe with all its hundreds of billions of galaxies and almost countless stars spanning tens of billions of light years may not be the only one. Instead, there may be an entirely distinct universe, distantly separated from ours and another indeed. There may be an infinity of universes, all which their own law of physics, their own collection of stars and galaxies. If stars and galaxies can exist in those universes, and maybe even their own intelligent civilization.
I see. What about you, Siti? Whether you need a new villain or an old Spider-Man, your sci-fi movie will sound more scientifically respectable if you use the word multiverse. The Marvel multiverse puts different versions of our universe out there. Somewhere in these films, with the right blend of technology, magic, and imagination, travel between these universes is possible. Could there be other Earths? Could there be other people out there who look a lot like us? On a planet like looks like ours. Scientifically, it's possible. Because we don't know how big our universe actually is. We can see billions of light years into space, but we don't know how much more space is out there beyond what we can see. If there is more space out there, full of galaxies, stars, and planets, then there are more and more chances for another Earth to exist. Somewhere, with enough space and enough planets, and possibly become like live. The fiction of the Marvel multiverse stems from the ability to travel between these other Earths. There's a good reason why Doctor Strange needs to use magic for this. According to Albert Einstein, we can't travel through space faster than light. And while more exotic ways to travel around the universe are scientifically possible to our house, for example, we don't know how to make them. The universe doesn't seem to make them naturally, and there is no reason to think that connect us to another Earth rather than some random part of empty space. So, almost certainly, if another Earth is out there somewhere, it's unimaginably far away, even for an astronomer. So, is there a multiverse? In this cycle of the scientific method, the multiverse is an exploratory phase. We got an idea that might explain a few things. If it was true, it makes it worthy of our attention, but it's not quite science yet. We need to find evidence that is more direct, more decisive. Something left over from the aftermath of the multiverse generator might help. A multiverse idea could also predict the winning numbers on our lottery ticket. However, Doctor Strange explains the multiverse is a concept about which we know frighteningly little.
That's really amazing. By the way, not long ago, I got interested in a quantum theory, but still can't really understand myself. Can you guys tell me?
Well, if that's the case, we all know who can help you with.
Why do you guys look at me like that? Anyway, I'll help you now. I will inform you about the definition of quantum physics. Quantum physics is the study of matter and energy at the most fundamental level. It aims to uncover the properties and behaviors of the very building blocks of nature. While many quantum experiments examine very small objects such as electrons and photons, quantum phenomena are all around us, acting on every scale. However, we may not be able to detect them easily in larger objects. This may give the wrong impression that quantum phenomena are bizarre or otherworldly. In fact, quantum science poses gaps in our knowledge of physics to give us a more complete picture of our everyday lives. Okay, first of all, the future is always uncertain. Will it rain tomorrow? Nobody knows the answer to such questions. But in case we may have information that makes the positive answer more or less appropriated. If we are in the Great Ocean Desert and it's winter, it's extremely unlikely to rain tomorrow. But if we are in Delhi in the middle of the monsoon, it will almost certainly rain. Physics is about predicting the future. Probability enters physics in two ways, through uncertain data and through the system being subject to random influences. In the first case, we could make a more accurate prediction if a property of the system, such as the length or temperature of the pendulum, were more precisely characterized. That is, the value of some number well defined. It's just that we know the value very accurately. The second case is that in which our system is subject to inherently random influences. For example, to the graph that make us uncertain. What will be the final temperature of the weather?
Oh no. Oh no, I get it. Thank you so much. Anyhow, it just come to my mind. We studied physics in school back then, right? So I interested to what you guys think about physics lesson.
So, in my opinion, from what I know about physics is that physics is the branch of science that deals with the structure of matter and how the fundamental constituents of the universe interact. Physics is the study of the relationship of object, force, and energy. It studies objects ranging from the very small using of quantum mechanics to the entire universe using general relativity. Physics also explains gravity and the way things move according to Newton's law of motion. It also helps us understand behavior and movement of energy such as heat, light, and electricity. The example is like the sound of the headphone. Small speaker in your headphone use electricity and moving magnet to correct sound wave. The sound wave that come from the speaker bounce off your eardrums, which your brain interpret as music. Sound wave that you hear, whether they come from another portion of a speaker, bounce off object and move through the air and into your ear. You can use the wave to interpret where a sound is coming from and how loud it is. Other fun example of sound is like a dog barking in the distance, a creaking door on the other side of the room, and a tapping a pen on your desk. That's all I know.
I actually not a basic person, but either a math person. Maybe because my father is also a math person, but since I also studied in fact I'm a science major at junior high school, I want to add my few point. So physics is the study of the natural world, both seen and unseen. It is a broad subject that can be broken down into specific areas of study like electromagnetism, and optics. If you ask me, are physics hard than math? Uh, I'll say, uh, I'll say if you clearly understand the concept of math and physics, both are easier. Especially physics is based on concept application, imagination and visualization include basic subject, so it can be much more difficult for the bookworms and those who don't understand the concept. Then I hear, someone ask, why is physics so hard? It's because physics demand problem-solving skills that can be developed only with practice. It also includes theoretical concepts, mathematical calculation, and laboratory experiments that add to the challenging concept. We use physics in our daily activities. Uh, challenging concept. Is it really important in real life? Yes, we use physics in daily life activities such as walking, cutting, watching, cooking, and opening and closing things. Physics is the one of the most elementary science that contributes directly to the development of science and the development of new technologies.
That's agreeable. In any case, do you guys have heard about the controversial whether the earth is flat or round? What side do you think?
Well, I know it's gonna come up. The Earth is roughly a sphere. How do we know that the Earth is around? Like the other planets, the Earth is a sphere. It rotates around its own axis slowly but continuously and completes its rotation about once every 24 hours. As the Earth rotates, part of the Earth is facing the Sun and part of the faces away. This is why some parts of the world have day and night and at different times. There are a number of reasons why scientists know that the Earth is round and not flat. It turned out that we can test many of these reasons out for ourselves too. If Earth was flat, we will be able to look out and see very far. Assuming that there were no building in the way, we could see another city that hundreds of miles away, or a ship sailing out the sea. The boat would stay in a view no matter how far out to sea it went. However, if we look out standing on the ground, we can't see that far. We can look out into the distance and see a town that's a mile away, and a ship will slowly start to disappear from view as it gets farther away. This is because the Earth is around. The things in the distance are not visible because there is a curve to the landscape. One way to test this is to watch the sunset. Find a spot where you can see the sunset and also have a place close by where you can safely move higher, such as a tree or building, or even start lying down and then stand up. On the ground, the sun will eventually disappear beyond the horizon. When this happens, quickly to go your high spot. From there, you will be able to see the sun gain of brief time. You have probably seen that when the sun is out. It causes a shadow to form if it hits something. It turned out that we can use that shadow as another piece of evidence that the Earth is around. If the Earth were flat, then shadow would be the same length, regardless of location. This would mean that sun is hitting all places on Earth at the same angle, resulting in the same shadow. However, it turns out that this is not the case. If we were to the place to if we were to place two identical sticks in the ground in two different places on Earth, we'll find that the length of their shadows differs. This is because the Earth is around, and so the way the sun hits each location will be a bit different. This also explains why the sun sets at different time in different locations. The sun is in a different position and relation to different location. And so the timing of when it will lower in the sky and eventually disappear behind the horizon will change. This is also a reason that different parts of the world have different time zones. As one part of the world is facing the sun, on the opposite side of the earth will not. For example, the time in New York, United States is 12 hours different than the time in Beijing, China. For parts of the world that are closer together, indifference in time will be less. During a lunar the Earth passes between the Moon and the Sun. When that happens, the Sun projects Earth's shadow onto the Moon. When it happens, you can actually see the Earth's shadow if you look up at the Moon. If you do this, you'll see that there's a round shadow, not a flat one. A follow-up question might be whether the flat could be flat and round like a pancake. This is would cause the shadow on the Moon to be around, but the shape of the Earth to be flat. If the Earth were flat but rotating, the shape would be different for ellipses at different times of the day or night. Sometimes it would appear only as a line. The rest of the time it would appear like an oval or circle as it's spinning. However, we know that the shadow of Earth cast on the Moon during an ellipsis shadow has been circular regardless of time of day. This supports the idea that the Earth is sphere. After all this explanation, right? A number of ancient cultures believe that Earth is flat because simply they didn't know any better. But incredibly, there remain people today who still believe that the Earth is flat despite centuries of evidence proving the contrary. I can't believe people say that the Earth is flat.
Additionally, the shape of the Earth is always changing, isn't it? Sometimes this change is periodic, as is the case with daily tides that affect both the ocean and the crust. Sometimes the change is slow and steady, as with the drift of tectonic plates or the rebound of the forest after a heavy sheet of ice has melted. And sometimes the shape of the planet changes entirely. Episodic waste-driven events such as earthquakes, volcanic eruptions, or meteor strikes.
That's a good point. Aside from that, I have interest in regarding your explanations to planet.
So I will take this and okay, disclaimer, I only know two planets and this explanation will be short. So the first planet I'm going to talk about is Mars. It's the fourth planet from the Sun and the second smallest planet in the solar system. Being larger than the only Mercury, is a dusty, cold desert world with a very thin atmosphere. Mars is also a dynamic planet with this season and polar ice cap, and that explains the cold on the planet, canyon, and extinct volcano. That evidence that is was even more active in the past. And the second planet I'm gonna talk is planet Venus. Venus is the second planet from the Sun and Earth closest planetary neighbor. Even though Mercury is the closest to the Sun, Venus is the hottest planet in our solar system. Its thick atmosphere is full of greenhouse gas carbon dioxide and has clouds of sulfuric acid. So if you want to know more detail, check Google.
Interesting. You guys seem like astrology so much. Can you guys give clarification to the listeners who don't know what astrology is?
Okay, so from what I know, astrology is a type of divination that involves the forecasting of earthly and human events through the observation and interpretation of the fixed star, the sun and the moon, and the planet. Devoted belief that an understanding of the influence of the planet and star on earthly affairs allow them to both predict and affect the destiny of individual, group, and nation. Thought often regarded as a science throughout its history, astrology is widely considered today to be diametrically opposite to the finding and theory of modern Western science. To make it simply, I give you the detail of astrology is the study of influence that distant cosmic object, usually star and planet, have on human life, and the position of the sun, star, moon, and the planet at the time of people birth, not their conception. Okay, is set to shape their personality, affect their romantic relationship, predict their economic fortune, among other definitions. What like most people know about astrology is their sign, which refer to one of the 12 constellations of the zodiac, like Aries, Taurus, Gemini, Cancer, Leo, Virgo, Libra, Scorpio, Sagittarius, Capricorn, Aquarius, and Pisces. These 12 constellations, this is a form of sun sign astrology, which is the astrology upon which newspaper horoscopes are based. It is probably the simplest form because nothing more than the date of someone's birthday is needed to generate a sun sign horoscope. Also, many astrologers will tell you that this form of astrology is simplistic, that is produce very limited result. They're only saying that because they know astrology is fake. So,
Well, I'm not into astrology anyway, and I don't believe in astrology, but that's the point at which astronomy came to be known as a science, and astrology was acknowledged as not a science, but its popularity relies on factors that numbers can compute, and the availability to the stars for answer has no name. In fact, in recent years, it seems to have expanded. After all, a 2014 National Science Foundation poll found more than half of millennials think astrology is a science, and Arnold argues that even if astrology's answers are based on scientific study, the reason people keep turning to this ideas come down to something very real. A psychological phenomenon involves the human tendency for self-selection to visit for interpretations that match what we already found to be true.
That's absolutely fantastic. That's absolutely fantastic. Well, listeners, we'll talk and learn a lot today. That's it, our podcast today. Hopefully, it can be useful and increase your knowledge about science. Thank you everyone for your time. The group 7 will be all. Stay healthy and have a nice day.
so goodbye.
Bye.